The early 1930s were a strange and electric time to be an engineer. Across Europe and America, designers were throwing out the rulebook on what a flying machine was supposed to look like. Biplanes were giving way to monoplanes. Engines were getting stronger. Speed records were being broken and then broken again. It was the kind of era where a genuinely crazy idea could get funded, built, and flown before anyone had time to talk you out of it. And in the middle of all that ambition and experimentation, one aircraft stood completely apart from everything else. An Italian creation so bizarre in its appearance that serious experts would call it the ugliest airplane ever built, and so ahead of its time that the rest of the world would spend the next several decades quietly catching up to it. The story of the Stipa-Caproni begins not in a factory or a wind tunnel, but in a trench. Luigi Stipa was born in Italy in 1900. When the First World War came, he interrupted his university education and enlisted with the Bersaglieri Corps, one of the Italian Army's elite light infantry units, known for their distinctive wide-brimmed hats and their reputation for speed and aggression on the battlefield. Stipa survived the war and came home with the kind of focus that tends to follow men who have watched their youth disappear into a conflict they did not start. He returned to his studies, and he did not stop at one degree. He earned qualifications in civil engineering, then hydraulic engineering, then aeronautical engineering, thus building a technical foundation so broad that it would eventually allow him to see a connection that nobody else in aviation had managed to see. After graduating, Stipa joined the Italian Air Ministry and worked his way up through the engineering division until he reached the position of General Inspector of the Air Force Engineering Division. It was a title that gave him both the authority to pursue serious research and the access to the kind of resources that turned theoretical ideas into real hardware. And he had an idea, a genuinely unusual one. Stipa had become obsessed with a problem that most aviation engineers of his era had simply learned to live with. Conventional propellers were wasteful. Aircraft engines of the early 1930s lost a significant portion of their power to turbulent, disorganized airflow. The propeller spun, walked, it pulled air, but much of that energy scattered and dissipated before it could be converted into useful thrust. Everyone knew about the inefficiency. Nobody had found a satisfying solution to it. Stipa's background in hydraulic engineering gave him a perspective that pure aeronautical engineers did not have. He kept coming back to the Venturi principle, a well-established concept from fluid dynamics stating that when a fluid passes through a narrowing tube, its velocity increases. Engineers had known this for over a century. They used it constantly in hydraulics, in carburetors, in all kinds of applications. But almost nobody in aviation had thought to apply it directly to propeller design. Stipa saw the connection clearly. If he could enclose a propeller inside a carefully shaped tube that narrowed in the middle, the airflow passing through it would be compressed and accelerated. The result would be dramatically greater propulsive efficiency from the same engine. He devoted years to working through the mathematics at the Air Ministry, calculating the exact shape the tube's interior surface would need to take, the optimum design of the propeller itself, the most efficient distance between the leading edge of the tube and the propeller blades, and the ideal rate of revolution for maximum effect. Then he arrived at something he had not expected. When he calculated the inner surface shape required for maximum efficiency, it closely resembled the cross-section of an aerofoil. The tube itself, shaped correctly, would generate lift. The thing he had designed to improve propulsion would also, as a side effect, help the aircraft fly. He called his invention the intubated propeller, and he was convinced it could change aviation permanently. Stipa published his findings in the Rivista Aeronautica, one of Italy's leading aviation journals, alongside detailed designs for a small single-engine test aircraft that would demonstrate the concept in actual flight. The publication attracted attention, but Stipa understood that a paper, however well-reasoned, would not be enough. He needed to build the thing and fly it in front of people who could see it working with their own eyes. He petitioned the Italian fascist government directly, requesting funding for a full-scale prototype. The timing helped him. In 1932, Mussolini's regime was actively hunting for opportunities to demonstrate Italian technological superiority to the rest of the world, and aviation was one of the fields where national prestige felt most visible and most valuable. Despite the radical nature of what Stipa was proposing, the government said yes. The Air Ministry approved the funding and began looking for a manufacturer capable of building something no aircraft factory had ever attempted before. They needed someone technically skilled enough to handle the engineering challenges and bold enough not to be frightened off by how strange the whole thing looked on paper. As it turned out, Italy had exactly the right man, and his name was already a legend. Count Gianni Caproni di Toledo had been building aircraft since 1910, when he constructed the very first airplane ever made in Italy. He had taught himself to fly, and in the early years he had designed his machines largely through trial and error, and crashing several prototypes before he managed sustained flight. But Caproni learned at a remarkable rate. By 1914, just 4 years after his first attempt, he had produced the world's first single-seat tractor engine fighter with a forward-firing machine gun, an achievement that placed him at the absolute forefront of military aviation before the First World War had even begun. When the war came, the Italian military gave Caproni one assignment: build bombers. He delivered a series of increasingly large multi-engine aircraft that became some of the most formidable strategic bombers of the entire conflict. His CA-3 series carried out long-range raids against Austrian targets. This and the sheer scale and ambition of his designs gave him an international reputation as a man who was willing to go bigger and bolder than anyone else in the industry. After the armistice, most aircraft manufacturers pulled back and played it safe. Caproni did the opposite. His most spectacular post-war attempt was the Caproni CA-60 Transaereo, an enormous flying boat designed to carry 100 passengers across the Atlantic. The machine had 9 wings arranged in 3 sets of 3, 8 engines, and a hull the size of a houseboat. It lifted off Lake Maggiore in March 1921, climbed briefly, then nose-dived straight into the water and broke apart. The wreckage caught fire overnight under circumstances that were never fully explained, and the CA-60 was never rebuilt. But the failure did absolutely nothing to reduce Caproni's appetite for unconventional projects. He kept building throughout the 1920s, and when the Air Ministry came looking for someone to construct Stipa's radical prototype in 1932, the answer was obvious. The contract called for a single flyable aircraft built around the intubated propeller concept. What that meant in practice was a fuselage that was not a fuselage in any conventional sense. It was a short, fat, barrel-shaped tube made primarily of wood, open at both ends, narrowing toward the middle to form the tapered duct the Venturi principle required. Air would enter through the wide front opening, get compressed as it passed through the narrowing section where the propeller was mounted, and exit through the rear with significantly increased velocity. The entire body of the aircraft functioned as one single massive ducted fan. Mounting the engine inside this tube required engineering that had no precedent. A single 120 horsepower de Havilland Gypsy 3, A 4-cylinder inverted air-cooled inline piston engine was installed in a nacelle suspended at the center of the duct, with the 2-bladed propeller positioned flush with the leading edge. The engine sat behind the propeller at the midpoint of the tube, and the nacelle had to be supported by structural members carefully positioned to avoid disrupting the airflow that the whole design depended on. Every component inside the tube had to sit in exactly the right place. Even small disturbances to the flow could compromise the efficiency gains Stipa had spent years calculating. The wings created their own problems. The aircraft was configured as a mid-wing monoplane with elliptical wings attached directly to the tubular fuselage. The main spars had to pass completely through the tube and through the engine nacelle inside it, making the internal structure far more complex than the simple barrel-shaped exterior suggested. From the outside, it looked almost comically simple. From the inside, it was one of the most intricate small aircraft anyone had attempted to build. The world was about to see something it had never seen before. The finished aircraft was a strange thing to look at. The wingspan stretched nearly 47 feet across. The fuselage was barely 20 feet long. The result was a machine that was more than twice as wide as it was long, squat, and barrel-shaped, sitting low to the ground on stubby fixed landing gear with wheel spats. It looked less like an airplane and more like someone had attached wings to an oversized oil drum and dared it to fly. No other aircraft in existence looked anything like it. Gross weight came to 1,874 pounds. Empty weight was 1,257 pounds. The strange machine was complete. Now someone had to fly it. On October 7, 1932, Caproni Company test pilot Domenico Antonini climbed into the forward cockpit and prepared for the first flight. Ground crews had already run the de Havilland engine through its checks. The 2-bladed propeller was spinning inside the barrel fuselage, pushing compressed air through the tapered duct with a sound that observers immediately noticed was different from anything they had heard before. Quieter, more muffled, as if the tube itself was swallowing part of the engine noise before it could escape. Antonini released the brakes. The aircraft rolled approximately 590 feet before lifting cleanly into the air. What the people watching saw next stopped them. A stubby barrel-shaped machine climbing steadily away from the field, its wide wings holding it aloft, looking for all the world like a piece of industrial equipment that had somehow decided to become an aeroplane. The flight data confirmed what Stipa had spent years calculating. The intubated propeller was working. The compressed airflow through the Venturi-shaped fuselage was converting a greater percentage of engine power into usable thrust than a conventional open propeller of the same size and rating could manage. The aerofoil-shaped interior of the duct was generating additional lift exactly as predicted. It's supplementing the wings in a way nobody had ever achieved before on a production airframe. The numbers that came back from those early flights were remarkable. Landing speed was just 42 miles per hour, significantly lower than anything with comparable power and wing loading could match. The landing roll was approximately 590 feet, identical to the takeoff distance. The rate of climb exceeded other aircraft in its power and weight class despite having only 120 horsepower available. Service ceiling reached approximately 12,100 feet. Wing loading sat at just over 9 pounds per square foot at maximum gross weight. These were not the numbers of an ugly failed experiment. These were the numbers of something that worked. There was one more unexpected finding. The Stipa-Caproni was noticeably quieter than other aircraft with engines of similar output. The tubular fuselage contained and directed engine noise forward and rearward through the duct openings, rather than letting it radiate in all directions. Nobody had designed for this. It happened anyway. After Caproni's team completed their initial series of flights, the prototype was transferred to the Regia Aeronautica. Military test pilots at the research facility at Guidonia Monticello, northeast of Rome, took the aircraft through a fresh round of evaluation. Their findings matched Antonini's almost exactly. Every pilot commented on the extraordinary stability, confirming that the aircraft held course with minimal correction. Several noted that the stability had crossed a line into something that felt almost like resistance, one as though the machine had its own opinion about where it wanted to go. The low landing speed continued to impress everyone who flew it. Military pilots who had spent careers landing conventional aircraft were genuinely surprised at how slowly the Stipa-Caproni could approach a runway and how short the roll was once the wheels touched down. But the Regia Aeronautica was not evaluating the aircraft against a theoretical ideal. They were evaluating it against machines already in service, and against that standard, the answer was clear. The tubular fuselage that made the intubated propeller work also produced an enormous amount of aerodynamic drag. The blunt barrel-shaped body pushed through the air with far more resistance than any streamlined conventional fuselage. And that drag penalty was severe enough to cancel out every efficiency gain the ducted propeller system delivered. Top speed was limited to 83 miles per hour. Contemporary single-engine aircraft with similar power were going faster. The aircraft designed to demonstrate a more efficient approach to flight could not outperform the machines it was supposed to replace. The Regia Aeronautica canceled further development. No additional prototypes would be built. Stipa had always understood this would happen. The single-engine prototype was never his real vision. It was a proof of concept, a demonstration built to show that the intubated propeller worked in the air and not just in calculations. His actual ambition was far larger. He had sketched designs for multi-engine flying wing aircraft where several ducted propellers would be integrated directly into an enormous airframe. In those configurations, the drag problem would largely disappear because the ducts would make up a small proportion of the total structure rather than constituting the entire fuselage. Some of his blueprints featured as many as 6 engines housed in ducted nacelles across wingspans that dwarfed anything flying at the time. None of those designs ever left the drawing board. But Stipa moved quickly to protect what he had built. He filed patents for the intubated propeller not only in Italy, but also in the United States and Germany, securing legal ownership in the 3 countries where aviation development was advancing fastest. The American patent was issued in February 1937 under the title Airplane, covering the core principles of the ducted propeller system. Stipa believed the idea had value far beyond what a single slow prototype had demonstrated. He intended to make sure nobody could use it without his knowledge. He was right about the value. He was wrong about being able to protect it. The military had moved on. The Italian government had other ideas. Even after the Regia Aeronautica canceled the program, the fascist regime recognized something the test pilots had missed. The Stipa-Caproni was visually extraordinary. It looked like nothing else on Earth, and in the world of newsreels and propaganda publications, that mattered enormously. The government promoted the aircraft as proof of Italian technological daring and engineering genius, with articles and technical papers circulated across France, the United Kingdom, Germany, and Italy itself. The academic and engineering communities responded with genuine interest. In the United States, the National Advisory Committee for Aeronautics obtained detailed data on the aircraft and conducted its own independent analysis, eventually publishing its findings as Technical Memorandum Number 753, titled Stipa Monoplane with Venturi Fuselage. The report treated the concept seriously, documented the aerodynamic principles, and made the Italian results available to every American engineer who wanted them. The leading aeronautical research body in the world had looked at Luigi Stipa's barrel-shaped flying machine and concluded it was worth studying carefully. The rest of the world was paying attention. Stipa just didn't know yet what they were going to do with what they had learned. If you want breakdowns like this, subscribe now. These are the stories they don't put on the placard. In Germany, a parallel development appeared 2 years after the first flight. In 1934, German engineer Ludwig Kordt patented a ducted fan system operating on principles that were strikingly similar to what Stipa had demonstrated in the air over Italy. The Kordt nozzle enclosed a propeller within a shaped duct to improve thrust efficiency. The same fundamental idea. Applied not to aviation, but to ships, the system proved highly effective on vessels requiring high thrust at low speeds, and the Kordt nozzle remains in use on tugboats and working vessels around the world to this day. Whether Kordt developed his design independently or drew on the widely published Italian research has never been definitively settled. The timing and the similarities are difficult to look past. France took the most ambitious step. French military planners saw the intubated propeller as a potential solution for a new generation of combat aircraft and commissioned a night bomber incorporating ducted propellers based directly on the Italian designs. The contract went to A&F Moreau, and the resulting aircraft was designated the BN-4. The specifications were genuinely impressive for the mid-1930s. A crew of 4 retractable landing gear, 2 power-operated gun turrets, a wingspan of 59 feet, a projected top speed of 233 miles per hour, a range of 1,242 miles, and a service ceiling of 33,136 feet. These were not the numbers of a curiosity. These were the numbers of a serious combat aircraft. The BN-4 could have proven that the intubated propeller worked when scaled up to a real warplane. It never got the chance. In the mid-1930s, the French government nationalized the aviation industry, merging private manufacturers into state-controlled groups and reassigning contracts across the board. The upheaval swallowed dozens of programs, and the BN-4 was among them. The night bomber was shelved before a single airframe was assembled. Another door closed. Then the Second World War came, and Stipa watched Germany deploy the V-1 flying bomb against England. The weapon used a pulse jet engine to drive an unmanned airframe carrying a warhead across the English Channel, and Stipa became convinced the Germans had stolen his patented designs to build it. He pointed to his patents filed in Germany and argued that the ducted engine concept had been lifted directly from his intubated propeller. The engineering community disagreed. The V-1's Argus pulsajet operated on a completely different principle, a series of controlled fuel and air explosions inside a resonating tube, with intake valves opening and closing rapidly at the front to sustain the combustion cycle. There was no propeller, no venturi compression, no aerofoil-shaped duct. The resemblance was superficial and the claim was broadly rejected. But Stipa remained adamant. The perceived theft deepened a bitterness that had been building for years, a growing sense that the world was using his ideas while refusing to acknowledge where they had come from. The most direct successor came from Italy itself. In 1940, The Caproni company flew a new aircraft called the Caproni-Campini N1. The connection to Stipa's work was not coincidental. The N1 used a conventional 900 horsepower Isata-Fraschini radial piston engine to power a variable pitch ducted fan compressor enclosed inside the fuselage. Air entered through a large nose intake, was compressed by the engine-driven fan, and passed into a combustion chamber in the tail where additional fuel was injected and ignited. The heated gases exited through a rear nozzle, producing thrust that looked and behaved remarkably like what a jet engine would produce. The N1 completed a well-publicized flight from Milan to Rome on November 30th, 1941, and the Italian government declared it the first jet-powered aircraft in history. That claim was technically incorrect, said the German Heinkel. He-178 had achieved true turbojet-powered flight in August 1939, though the Germans had kept it a military secret. The N-1 was never practical as a combat aircraft. Its performance was inferior to conventional fighters of the era, and only 2 were ever built. But the tail combustion chamber, where fuel burned in the compressed airstream, functioned on exactly the same principle as a modern afterburner. Italy had a legitimate claim to flying the first aircraft ever equipped with that technology. The conceptual line from Stipa's intubated propeller to the Campini motorjet was direct and clear. Both used a piston engine to drive a ducted compressor. Both managed airflow through a shaped internal channel to increase propulsive efficiency. One had led to the other. After the war, jet aviation exploded. So turbojet and turbofan engines transformed everything, and Stipa watched it all from the outside, becoming increasingly convinced that the modern jet engine had descended directly from his intubated propeller. The core principle was the same. Compress air through a ducted fan to generate thrust. Rely on the shape of the duct to improve efficiency. He had demonstrated that in October 1932 above an Italian airfield in a machine everyone called ugly. Several aviation historians acknowledged the similarities. A 1959 academic publication on jet propulsion explicitly classified the Stipa-Caproni as an early jet aircraft and described it as a predecessor of modern jet-powered flight. The quart nozzle was in use on ships around the world. The afterburner principle had been demonstrated in Italian skies. Yet ducted fan technology had become fundamental to how humanity moved through the air. And nobody was giving Stipa the credit. He spent his remaining decades watching the world build on ideas he believed he had pioneered, frustrated by an aviation establishment that treated his creation as an interesting footnote rather than the milestone he knew it to be. Luigi Stipa died in 1992 at the age of 92. The patent had been issued, the flights had been flown, the papers had been published, and the world had largely moved on without saying his name. But his story did not end there. In Australia, an aviation enthusiast named Lynette Zuccoli and the team at Aerotech Queensland decided to do something about it. They designed a 3/5 scale flying replica of the Stipa-Caproni, but accurate down to the paint scheme and the Italian flag markings on the rudder, powered by an Italian-made Simonini racing engine. Construction was completed in 1998. 3 years later, in October 2001, 69 years to the month after Domenico Antonini's historic first flight, Australian pilot Bryce Wall took the replica into the air and completed 2 test flights, each covering approximately 600 meters at about 6 meters altitude. He reported that the small aircraft was remarkably stable, that it behaved almost exactly as the Italian pilots had described the original nearly 7 decades earlier. The machine that critics had dismissed as the ugliest airplane ever built still flew precisely as its creator had designed it to. Stipa had been right all along. He just never got to hear anyone admit it.